morning, dear students. In the previous classes, we have discussed about the graphical representation of first and second equation of kinematics. Those are V is equal to U plus AT, and secondly S is equal to UT plus half AT square we have discussed. Now we have left the third equation to prove, and you know the third equation was twice AS is equal to V square minus U square. Twice AS is equal to V square minus U square. These equations we have to prove represent graphically. In the first two cases we took a diagram, and the diagram will remain same in this case also. So let us take a look about the diagram. What will be it? Diagram is quite similar, no change in this case. This is the y-axis, where this is your x-axis, and in this case I told you this is time, and this side we have got the velocity. Remember, this equation is also known as position velocity equation. This is also known as position velocity equation. Position time, then previous was your position time, then your this is position velocity equation. So in this case, if I consider an object that is in uniform acceleration, I have already mentioned you that in this case all the cases we will consider a body that is in uniform acceleration. So in this case, if I consider this is to be 0, and we have considered that initial velocity of the body that is not 0. So we will start from this point. That means this body has got some amount of initial velocity. So this will be the graph, and let us suppose this point is A and this point is B. That means this will indicate us the uniform initial velocity, and this is the ending of velocity. This is final velocity. So I will join this line, and I will join this line too. I have joined this line, and this line will also be joined, so that we can derive this particular equation. And this is A, B, C, this is D, and this is point is E, and this is final velocity V, this is initial velocity U. Okay, as per remember that the assumption I told you that in this case OE and BC are equal, so we'll write OE is equal to BC is equal to final velocity. OE is equal to BC is equal to final velocity. Similarly, OA is equal to DC, CD is equal to OA is equal to CD is equal to initial velocity. AD is equal to OC is equal to time. AD is equal to OC, and this OC is equal to your time. Now we assume, since this is position velocity equation, okay, first was velocity time equation, second was position time equation, and this is position velocity equation. Now we will go for it. See, since we know that position of the body is, I told you that the graph area enclosed within the graph, area enclosed within the graph. That means the area enclosed within the graph will be the position of the object. And in the previous case, we considered a triangle as the area and as a rectangular of the another area. But in this case, we'll consider as you can see that this is OABC. OABC is forming a trapezium. Okay, so if I write that S is equal to area of trapezium, which trapezium OABC. So I can write OABC is the trapezium. Now as we know that area of trapezium, how can we find out the area of trapezium? Area of trapezium can be found as the sum of two parallel sides divided by 2 into height. Okay, understand? So I'll write this is sum of parallel sides, sums of parallel sides divided by 2 into the height. This is the formula to find out the area of a trapezium. Now if I put the value of it, the sum of two parallel sides in OABC, OA and BC are the two parallel sides. So I'll write OA plus BC. BC and OA are going to be two parallel sides divided by 2 into height. In this case, the height of the trapezium will be OC. OC will be the height of the trapezium. So I'll write here as OC. Now if I put the value accordingly, S is equal to, what is OA means? Your OA will be your, this is OA will be initial velocity U, plus BC will be your final velocity V, U plus V by 2 into OC, this OC will be your T. This will be like that. Now finally we have found that S is equal to U plus V by 2 into T after putting their respective values. Now the value of T will put with something different type. That is, we don't put the directed T as here, and we'll find that value of T. As you know that acceleration of a body is equal to V minus U by T. We know it. This is the acceleration of a body. So this is acceleration of a body is A is equal to V minus U by T. So in this case, if I find the value of T from here, therefore T is equal to, it will be V minus U by A. This will be the value of T, and this value will put now. Understand? This is acceleration. A is equal to V minus U by T, and T is equal to, it will be what? V minus U by A. So this value will put in this equation. So let's see what comes. S is equal to U plus V by 2 into value of T you can put as V minus U by A, as you can write. So in this case again, this will be S is equal to, above if I write like that, U plus B V minus U, so it will be V square minus U square. Just some change in here. If I write this V plus U, this is V minus U, so this is V square minus U square. And below, if we take this is twice S, this implies twice A is equal to V square minus U square. Hence this is the required kinematic equation we had to prove. Twice A is equal to V square minus U square, position velocity equation. Okay, I don't think you have any problem. Diagram is as it is for the as you draw for a fast equation. So that is how we have graphically represented. We have graphically represent the all the kinematic three equations those we have, and what is you should do, you should practice at home, and it will be nice for you because these are very essential concept.